This comes out of section 11.3, the binomial theorem. I left off in the last example saying we should be able to come up with a shortcut for doing expansions. And the shortcut is this. It says right on your formula sheet that in the expansion of, it's right at the bottom left of your formula sheet, x plus y to the n, that the general term, which we'll call t k plus 1, is equal to n choose k, x to the n minus k, y to the k. Now, first time looking at that formula, it just looks like a bunch of jargon. Don't even know what that's supposed to mean. But in the last example, we found that when we did x plus y to the fourth, that the first term of that, for example, was 4 choose 0, x to the 4 minus 0, y to the 0, which actually just gave us 1 x to the 4 times 1, which we don't really need to write these 1's there, just gave us x to the 4. The next term was 4 choose 1, x to the 4 minus 1, y to the 1. So it gave us 4 times x cubed times y, 4x cubed y. And we kept going, and we had all the terms in this expansion. The good thing for us, I suppose, in this section is that they usually only ask us for a term in the expansion, most commonly, unless it's a teaching example or something where we're just getting drilled home how to do this thing. So the next example is here. And we're asked to find the first three terms of the expansion of 2p minus 3q to the 7. Now, never in my life have I multiplied 2p minus 3q times 2p minus 3q times 2p minus 3q over and over and over 7 times and actually combine all the like terms and come up with this thing, because it would take too long to do it. I'm very likely to make some kind of mistake in there, and there's a much shorter way. Basically what I want is term 1, and I want term 2, and I want term 3, which is nice because this thing actually would have 8 terms. There's always one more term than whatever the exponent is. So in this case, 8 terms would be a lot of work. So I'll make it as if it's a little table here. N in every case here is whatever the exponent is, which is 7. So n is 7 all the way along. Instead of x in this particular question, we're using 2p. So our x is going to be 2p all the way along. And instead of a y, we're using negative 3q. So our y is going to be negative 3q. The one thing that is different for each of these is what does k equal. Now the one thing you have to get used to is that it's tk plus 1. In the formula that says tk plus 1 equals n choose k, x to the n minus k, y to the k, the general term of the expansion of x plus y to the n, that's as it's put on your formula sheet. So for term 1, I actually want k to be 0. And what I will do for the calculation is I'll say, oh, that's going to be 7 choose 0, 2p to the 7 minus 0, and then negative 3q to the 0. So what does that end up being? 7 choose 0 just equals 1. 2p to the 7 means 2 to the 7 times p to the 7, which is 128p to the 7. And then this to the 0 just equals 1. So my first term is 128p to the 7. So I'll do the same thing for term 2, except the only thing that changes is I let k equal 1. So I'm going to have 7 choose 1, 2p to the 7 minus 1, and then negative 3q to the 1. So similar type of work here. I have 7 choose 1, which is 7, 2 to the 6, which is 64, p to the 6, and then negative 3q. So at that point, you probably, if you haven't already, you break out your calculator and you say, what does 7 times 64 times negative 3 equal? And it gives me negative 1344, and I have p to the 6q. So the next term in this expansion is negative 1344 p to the 6q. For term 3, the only difference is I let k equal 2. So I have 7 choose 2, 2p to the 7 minus 2, and negative 3q to the 2. So we figure out what 7 choose 2 is, and it's 21. We have 2p to the 5, so we have 32p to the 5. And if we square everything in those brackets, the negative goes away, we have 9q squared. So once again, we're going to drop our calculator with 21 times 32 times 9, and it gives us 6,048, and we have p to the 5 q squared. So 6048 p to the 5 q squared. So if we were actually expanding 2p minus 3q to the 7, we would get term 1, term 2, term 3, and we get a whole bunch more terms because there'd be 8 altogether, but we were only asked for the first 3. Very labor-intensive example, somewhat repetitive, but repetitive is a good thing when you're just learning it for the first time, I suppose.